The idea of Earth's ground moving first started by American geologist Frank Taylor. He was struck by the similarity in shape between the coastlines of Africa and South America, and from this observation he developed the theory that the continents had once slid around. As he failed to provide sufficient evidence, his theory was ignored. 4 years later, in 1912, Taylor's idea was picked up in Germany by a theorist named Alfred Wegener, who investigated the theory by looking for fossils and plant anomalies. He found out that identical animal fossils turned up on opposite sides of the ocean. In other words, the same fossils existed on different continents. He wondered how this could be possible, because the distances were clearly too wide to swim. Did marsupials travel from South America to Australia? How did identical snails turn up in Scandinavia and New England? The fossil evidence supported Taylor's idea, and Wegener developed a theory that the world's continents had once existed as a single landmass that he called Pangaea. Pangaea was the place from which every life had originated before the continents later split apart and floated to their present positions. People did not really give the theory much attention until it was revised in 1920, leading them to believe that the continents really moved, but they were convinced that the continents moved up and down, not sideways. This vertical movement was a process called isostasy, but nobody actually had a good theory to explain why and how they moved up and down. One idea to explain that was the baked apple theory founded by Edward Suess. He suggested that early Earth, which was molten because of the huge reserves of heat its elements contained, had cooled and became wrinkled just like a baked apple, and that's how he thought ocean basins and mountains were created. However, the theory was explained to be nonsense. Many critics pointed out that if the baked apple theory was correct, this would have meant that mountains were distributed evenly on different continents and had the same age, which of course is not the case. Going back to understanding how similar fossils existed on different continents, geologists placed land bridges wherever they were needed. A land bridge was drawn over the Atlantic from France to Florida when it was discovered that an ancient horse named Hipparion lived in both locations at the same time, and many other examples of land bridges, but again, there was no evidence that such bridges ever existed, so this theory was also ignored. Again, Wegener made another observation. He asserted Greenland was drifted west, but he could offer no explanation for how the land masses moved about, so his ideas were newly dismissed. But in 1944, it was finally Arthur Holmes who came up with a suggestion for the movement of land masses. He was the first scientist to understand that radioactive warming could produce convection current within the Earth. In other words, the radioactive warming could produce heat flows that in theory could be powerful enough to slide continents around on the surface. So Holmes published his theory called the continental drift theory, the one that actually prevails today. However, at that time, the theory had been criticized, even by Holmes himself, thinking that his hypotheses sounded fantastic. And Americans stuck to the belief that continents occupied their present positions forever. Interestingly, oil companies' geologists had known all along that there had to be some sort of Earth movement for them to be able to find oil. There was one other major problem with Earth theories that no one had ever resolved. Where did all the sediments go? Every year, the Earth's rivers carried massive volumes of eroded material to the seas, million tons of calcium for example. Where did it all go? Can they be found as layers on the ocean bottoms? Scientists ignored this question and no one bothered investigating, but eventually, there came a point when they could no longer ignore it. In 1945, a mineralogist named Harry Hess, who was in charge in the Second World War, discovered that there were no sediments on the ocean floor and that it looked very young. He wondered, because if the ocean floors were ancient as everyone assumed, they should be thickly covered with sediments. However, he only found the ocean's gooey smoothness. In the upcoming years, oceanographers were taking more and more sophisticated surveys of the ocean floors. In 1950, they found out to their surprise that most mountains on Earth were underwater. Looking further at that, during the laying of ocean floor cables in the 19th century, they discovered a rift down the middle of the mid-Atlantic ridge. This seemed to suggest that the Earth was splitting apart at the seams, like a nut bursting out of its shell. It was an absurd notion, but the evidence couldn't be denied.
In 1960, core samples showed that the ocean floor was quite young at the mid-Atlantic ridge but grew older as you moved away from it, east or west. Hess considered this matter and realized that this could mean only one thing. New ocean crust was being formed on either side of the central rift, then being pushed away from it as more crust came along behind it. The Atlantic floor was like two convoyer transportation belts, one carrying crust towards North America, the other carrying crust towards Europe. The process became known as seafloor spreading. When the crust reached the end of its journey, in other words the boundary of continents, it sunk back into the earth in a process known as subduction, and that explained where all the sediments went. It was being returned inside the earth. It also explained why ocean floors everywhere were so young. It was a beautiful theory that explained a great deal of things, and Hess elaborated his arguments in an important paper. But again, his findings were ignored.
Still, in 1980, after all the meetings, the observations, and the evidence, one American geologist in 8 still didn't believe in plate tectonics. Today we know that the Earth's surface is made up of 8 to 12 big plates and 20 or so smaller ones, and that they all move in different directions and at different speeds. Some plates are large and comparatively inactive, others are small but energetic. The plates have only a minor relationship to the land masses that sit upon them. Some plates are much larger than the continents they are associated with. Some continents sit on several plates and not just only one. Other planets have more than one continent sitting on them. Iceland, for example, is split down the middle, which makes it technically half American, half European. New Zealand, meanwhile, is a part of enormous Indian Ocean plate, even though it is nowhere near the Indian Ocean, and so it goes for most plates. The constant turmoil keeps the plates from fusing into a single immobile plate. Assuming things continue much as they do now, the Atlantic Ocean will expand until they eventually is much bigger than the Pacific. Much of California will float off and become a kind of Madagascar of the Pacific. Africa will push northward into Europe, squeezing the Mediterranean out of existence. These are future outcomes, but not future events. The events are happening now. As we sit here, continents are adrift like leaves on a pond. Some continents, such as Europe and North America, are parting at about the speed of fingernails grow, roughly 2 meters in a human lifetime. That's what we do not really appreciate or even notice the changes. Look at the globe, and what you are seeing really is a snapshot of the continents as they have been, or just 0.1% of the Earth's history. Earth is the only one among rocky planets to have plate tectonics. Scientists do not understand why they exist, only on Earth and no other planets with similar elements like Earth. It is thought, but really nothing more than a thought, that the continuous movement of the tectonics is an important part of the planet's organic well-being, and maybe that's why our Earth is habitable and others not. In any case, plate tectonics explain the surface dynamics of the Earth, how an ancient Hipparion, as mentioned before, got from France to Florida, for example. In addition to that, it has also explained many of Earth's internal actions, such as earthquakes, the formation of island chains, the location of mountains, the origins of life itself. There was hardly a matter that wasn't directly influenced by this remarkable new theory of the plate tectonics. Geologists have found themselves in the position where the whole Earth suddenly made sense. There are a few things that the theories of tectonics cannot explain: the rising of the country of Denver, that the slight appearance that Indonesia is slowly drowning and dragging Australia down with it.